Hello everyone, welcome back to Linked Frequency. In this tutorial, we are going to learn about how to create a automatic AC switch circuit using a human detection sensor, which is a passive infrared sensor which is used most of the time in the DIY segment. This is the 11th tutorial of practice project for PCB designers, and I am Vaibhav Sugandhi, passionate PCB designer and technology startup founder. This tutorial is focusing on the utilizing this PIR sensor available in the market, which is absolutely used for detecting the human presence in the area of that particular sensor to trigger certain actions. In our case, we are going to use it to turn on the lights in the room by using the relay module as an AC switch. So this is all about this tutorial. Let's get started with our black box analysis. First thing is, we have a black box analysis here. This is a device which is used by the AC equipments or the AC components in our home. That's why we are using a 230 volt AC directly connected to the entire system. Of course, we are converting that AC into a DC by using the AC to DC power supply. Why? Because our electronic works on the DC voltage, not directly on the AC voltage. We are not using any battery or any kind of a storing devices here which stores the energy, because we do not use this switch when there is no power supply. That's why we are using the AC power supply or AC to DC converter circuit in the middle. Thereafter, we will be having a main controlling unit which will be controlling the algorithm or the process of executing the commands based on the PIR sensor module. And of course, we will be having a USB programming for that controller or maybe the development board so that we can program it however we want it. We will be also having a PIR sensor module for accessing the data, whether there is a human presence in that particular area or not. And thereafter, a 5 volt relay module or a relay circuit is being used to switch on the AC appliances or any fan or maybe a bulb or maybe any kind of a AC appliances that you want to control based on the presence of human. Lastly, there will be a SMUM indicating LEDs to indicate there is a power supply, and also there is a signal activated from the PIR sensor. These are the bare minimum basic block diagram or the black box analysis of our project AC, automatic AC switch using a PIR sensor. Now let's jump into the white box analysis. Again, the datasheet analysis and the morphological chart are the essential part of the entire design activity, which you have to do by default, which I'm skipping to avoid the video length to becoming a too long. Here we have a 230 volt AC, 50 Hz frequency. This is in India, so we have a 230 volt. If you are in other countries where 110 volt DC or 110 volt AC is available, that still works with the suitable power supply which converts 110 volt AC into a 5 volt DC. Now we have a 230 volt AC, 50 Hz frequency, so we will be using the HLK5M05 SMPS module which converts the 230 volt AC into a 5 volt DC. Why we need a 5 volt DC? Because our entire electronic circuits works on the 5 volt DC or 3.3 volt DC. Since we have a 5 volt relay module and also the sensor is also using a 5 volt, that's why we are trying to convert a 230 volt AC into a 5 volt DC. So Arduino Nano V3 uses the 5 volt at the V in pin, and micro USB is given to that particular development board so that you can program it however you want it. And we are using a SRD05 VDC relay module for the entire switching application. I hope you remember in our previous tutorial, we discussed how to create a 2-channel relay module using the same relay part number. And we are going to use the same relay part number and the circuit diagram to create one for our today's application. This is how our white box analysis looks like. Now let's jump onto the tool called EasyEDA to start with our design activity. First thing is, I'm going to file and create a new project, and I'll name this project as automatic AC switch. I'll not give any description further now because it's quite simple to understand by looking at the title itself. So I'll click on save directly. Now we have our project created here, and now I'll go to the file once again and I'll create a schematic. Probably an updated version of EasyEDA has some new updates which even I'm not so familiar right now. I think the schematic sheet will not be created by default by creating the project in this case. Maybe or may not be. Right now we'll go ahead and we'll create our schematic sheet by the standard procedure. And once I save this, probably it'll ask for saving it as a specific project. I think I'll go and select the project and I'll click on the save option. Voila. Now you can see that it is reflecting on the project folder. Now let's jump into the naming it, and our company name is Linked Frequency. Alright, so now let's jump into the bringing the component on the canvas and start designing as we always do. Alright, now you can see that there is a AC to DC converter circuit in this, which we have designed as per our white box analysis. And then you can see that there is an indicator LED which will indicate there is a successful conversion of a power or not. You can maybe solder this one or may not be solder this one as per your requirement. And then we have a Arduino Nano Development board, which we have used only 3 pin among them. Of course, it is a overkilling development activity, but still, as it is a practice project and a development DIY project, so we are using only 3 pin among all the 20 pins available on the Arduino Nano Development board. And then we have a PIR sensor module and one more indicator LED just in case if you want to indicate any error or anything. And then we have a single channel relay module as we designed in our previous tutorial. So this is how our entire circuit looks like, very classic circuit of automatic AC switch using a PIR sensor. Now we will jump into the PCB design activity and we'll finish that as we always do. Alright, now you can see that this is how the PCB looks like for the automatic AC switch using a PIR sensor. Again, we have done a couple of new things in this particular tutorial, which I want you to recognize and understand them, how exactly it is done. First thing is, we have created this solid region which will exclude the copper pouring for the ground layer or the ground connection from this particular part of the area. This is nothing but a solid region. You can just select this solid region and create a square solid region so that you can exclude the ground pouring with the AC component. This is a AC input actually. I have forgot to add a text on this. We'll add that one as well. So we can add it as a AC in. So in this particular case, let's reduce the size to 1.25 probably, and the stroke width to be 0.2 only. So we'll keep it like this. So by looking at this connector, you can recognize that this is the AC input for the SMPS module that we have here, HLK module. So if our ground plane, which is a 5 volt ground plane, DC ground plane, if it interferes with the AC input, it may create a lot of problem in our digital circuitry. And this is a huge concept if you go for the higher end design or maybe intermediate design of PCB designing, which is also called as an analog ground and a digital ground. Right now, we are not going to jump and detail about that particular thing, and we are not addressing that entire thing in this particular solid region option. But we are creating some security to our digital circuit by creating a exclude solid area for the ground. Similarly, for the AC switching, that is our relay module, we are creating the same solid region. That is the first thing that we learned in this particular tutorial. And the second thing is, let me finish this one as well. Adding a silk layer on the AC outside with the COM pin NO and NC. I believe it is easy for anyone to understand which is a COM, which is not a COM by looking at the circuitry and all. So this is the first thing. And the second thing is very important, which we have to understand here is, when you are placing these components, we place them in accordance with the IPC standard. So when we are having a constraint with respect to space, on that time, we can create a PCB board with the odd shape that we discussed in our previous tutorial, like width and height of the PCB should be in the even number or the round figure number, so that it is easy for the mass production. But just now in this case, we are using a 95 and 55. Still it is a good number. The shape is good one, and still it is good for the mass production and all. There is no much problem, but it is always better to use the number which is always in terms of a 10 multiplication. 5 multiplication is also good one, like 95 is also good one, but highly recommended if you use a 90 mm by 50 mm or 60 mm by or 100 mm by 60 mm, something like that. 95 by 55 is still good, but do not use anything like 92 by 42 or 92 by 52. In any case, do not use such odd number. Of course, in very special cases where the constraints are very specific, like outer casing of the entire product is having a specific dimension, on that time you have to go with the dimension that you have fixed by the mechanical designing. Right now, as a DIY project and a general project, and you are designing the entire PCB from the first time, then make sure that you use the standard PCB size. So this is all about our PCB designing. And if I go to the 2D diagram or a 3D diagram, you can see that this is how the entire circuit looks like. Again, there are so many things which we can improve in this design, but since the video is going on, so I'm just trying to make sure that it is done in a best way possible at this point of time. So you can see here, Arduino Nano is here. This is the power supply, and this is the input connector, and this is the output connector. A relay module is with us, and LED for relay module is with us. PIR sensor is not having a 3D model at this point of time, but yes, you can see that the PIR sensor is also exposed to the open point, so that you can create a casing with the open circuitry. So this is all about our AC switch using the PIR sensor module. And as we already discussed, the PIR sensor is a general one. We are using the ready-made product from the off-the-shelf product in the market, and we are using that particular sensor output, which is available in the 2 different formats, and using that particular output to control our relay module to turn on and turn off any appliances. So again, if I give a brief introduction about this PIR sensor, we have a 2 potentiometer here, which is helpful for setting up the delay of the pulse that is generated and the duration of the pulse that is being generated by the PIR sensor. So if you study the datasheet of this particular sensor, you will get to know a lot of options possible with respect to the same sensor. And this is a RGB passive infrared sensor. So it's very quite amazing and very useful for the DIY project that we discussed so far. So this is all about automatic AC switch using a human detection sensor, that is PIR. I hope you enjoyed the entire tutorial, and I believe you have learned something new in this tutorial. Practice by yourself, and if you got any questions or if you need any clarifications, feel free to comment on the comment section. Consider subscribing to Linked Frequency, and see you again in the next video. Until then, tune yourself to make a difference.